Can you see the screen, Salwa?
The white blank screen?
Yeah, the white black screen. Blank.
Yes.
Okay. So we are going to start with polynomials. Now, to start with polynomial, few basics are there for polynomials. So first tell me,
Yes.
do you understand that how to identify the polynomial? If I will write 2 root x plus 32, is it a polynomial, Salva?
Yes.
Okay. If I'll write 3x to the power minus 1 plus 22, is it a polynomial?
Yes.
Okay. So we need to start from here. Okay, first the identification of polynomial. I'll cover it quickly. So this is our class 10 concept doesn't starts from here. It starts from quadratic polynomial. But you need to know what is polynomial. Okay, which was there in the before than class 10. In class 9 also you have learned polynomials, right?
Yes.
Okay, so if you have missed any key point over there, that is the main reason that here it is not getting clear to you and you are not understanding the basic. So the polynomial, the whole story started from there. Okay, quickly I'll be able to cover it, don't worry. So
Thank you.
there are two conditions. Okay, there are two
Okay.
conditions which needs to be fulfilled to become a polynomial. The first condition
Okay.
is the power of the variable has to be a whole number. If you are having any algebraic expression, you understand that if I'll write x square plus y square plus xyz, this is one of the example of algebraic expression. Why? Because xyz is there, right?
Yeah.
Okay.
Yes.
Now polynomial, this is not polynomial. Why? Because to become a polynomial, any algebraic expression needs to fulfill two conditions. The first condition is one and only one variable has to be there. Okay.
Okay.
Polynomial chapter is all about polynomials in one variable. In future or now also, always it will not be written that in one variable it will not be written, but we need to be clear that polynomial means polynomial in one variable. Here
Okay.
y is there, z is there. Okay, three different types of variable can we see over here, Salva?
Yes.
Okay, this is not fulfilling the first condition, hence we are not going to check the second condition, which says,
Okay.
so far it is making sense, right?
Yes.
Okay, so polynomial means polynomial in one variable. The second condition is the power of each and every variable. Okay, what each and every
Okay.
variable means, that means you will find x square plus x plus 35. Here how many variables are there? Only one. Okay, x
There are two variables, right?
x can be repeated, but only one type
Okay.
of alphabet can you see over here.
Yes. Only
That,
X.
okay, that is allowed. Okay, so
Okay.
only one type of alphabet has to be there, even though it is two times, three times, five times, or maybe
As many times?
as many times. Okay, this
Okay.
is completely allowed. Just give me a second. So yeah, as many times as possible. Okay, it doesn't like give any impact. Okay? It is still will be a polynomial. Now
Okay.
the second rule is power of each and every variable has to be a whole number. So here x, here x, here x, we are just checking the power of the variable. Okay, we are not checking the power of any number. Okay, the number which is multiplied in front. or this 30, this 30. We are not checking the power of the numbers. We are just checking the power of the variable. That means x, 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 x. Here, each and every variable power has to be a whole number. So the first power is 5. Is that a whole number, Salwa?
Yes.
Yeah. The
Yes, it is.
next power is 4.
Yes.
X to the power
4.
4. It's a whole number. Next power is 3. Is that a whole number?
3.
Yeah.
Yes, it is.
So all the powers of the variable are whole number.
Whole numbers.
Is it a polynomial? Yes.
Yes.
Two criterias are there. One variable has to be there, and each and every power of the variables has to be a whole number. Okay, if this two
Okay.
condition is getting fulfilled, then it's a polynomial, otherwise it's not a polynomial. Now you can see the question which I have given initially to you. 2 root x plus 32. Here one variable is there. Yeah,
Yes.
power of the variable is root x is there. Do you know root x can be written as x to the power 1 by 2?
Yeah. But it's not a
2,
whole number.
that's not a whole number. Okay, so the example which I have given, that's a algebraic expression but not a polynomial. Why? Because here the x power is not a whole number. Getting it?
Yes, ma'am.
Okay, next example which I have given initially, this 3x to the power minus 1 plus 22. Here only one variable is there. Yeah, power of the variable is a whole number. Is it a whole?
No.
No, it's not a polynomial. Clear?
Okay, ma'am. Yes.
Okay, so from here, polynomial came from where? Algebraic expression. Okay, it came from there only, but there are two conditions which applied over here. So far, any confusion, Salva?
No, ma'am.
Okay, you will always find example like this, that 1 by x square plus x to the power 4 plus 5. Is it a polynomial? So quickly you will say that this can be written as x to the power minus 2, right?
Yeah.
Do you know that?
So it's not a whole number.
Yeah, this power is not a whole number, hence not a polynomial. Even though one variable is there, it's not a polynomial. Okay.
Okay.
Now the next part came as uh, the name of the polynomial. Linear polynomial, quadratic polynomial, cubic polynomial. Do you understand the names?
Yes, like the number of variables they have.
Okay, so let's cover it. The first category of the polynomial is constant polynomial. According to the degree of the polynomial, we'll be checking the name of the polynomial. According to the degree of the polynomial. Now, what's degree? Let me help you reminding that what's degree. If we are having x to the power 4 plus 32 plus 25 x cube, okay, it can be like this. Here, the what is the degree of this polynomial, Salva?
4.
Yeah, the highest power of the variable. So according to the degree of the polynomial, there are names of the polynomial. You have learned when the degree of the polynomial is 0, the name of the polynomial. For example, the polynomial will look like just 32 or maybe just 24 or maybe just minus 5. Why? Because when we are having only 32, we are thinking it like 32x to the power 0. This is what going on in our mind. Can we write x to the
Yeah.
power 0? Yeah, that is
No.
just 1. Getting it?
Yeah, x to the power of 0 is x is 1.
Okay. Anything to the power 0 is just 1. Anything to the power 0 is just 1. So 32 can be written as 32x to the power 0. And
Okay.
hence it became a polynomial. One variable is there and power of the variable is a whole number, right?
Yes.
Okay. That's why we say anytime, anywhere, it will be written that 225. Is it a polynomial? You will say yeah. Okay. If anybody will ask that why it is a polynomial, you will say because 225 can be assumed as 225 x to the power 0, because x to the power 0 basically means 1. So we are just
1.
multiplying 1 over here. We are not doing any changes with the number. Okay. We are just multiplying 1.
Okay, ma'am.
Okay. And hence now it is fulfilling both the criteria of polynomial. Clear?
Yes, ma'am.
So this is one of the these are the few examples of degree 0 polynomial, and the name of this type of polynomial is, we call it zero polynomial or constant polynomial.
Okay.
So anytime, anywhere, it will be zero polynomial or maybe constant polynomial. You need to recall that, okay, degree is 0 over here. Okay.
Okay, ma'am.
When the degree of the polynomial is 1, for example, your polynomial will look like 2x plus 5 or maybe just 5x. Okay, here you can see the power of x, the highest power of x is 1, right?
Yeah.
This type of
So that
polynomial.
is the degree of
Yes.
x.
Okay, that is the degree of the polynomial, and according to the degree, the name is defined that it's called linear polynomial. So such polynomial where the degree is 1 are known as linear polynomial. Clear?
Yes, ma'am.
Okay, in your class, degree 2 polynomial basically we are having mostly. Okay, when the degree of the polynomial is 2, for example, if it looks like 2x square plus 5x plus 7, this is called as quadratic polynomial. Okay, here the highest power of the variable is 2, and you can keep on
2
checking, Salwa, that whatever example I am writing, every time, everywhere, it is fulfilling both the criteria of polynomial.
criterias of polynomial.
Okay, so here the highest power is 2, hence degree 2, and hence the name quadratic. Anytime, anywhere, you
Quadratic.
will see 4x square plus 8. What is the name? Quadratic. Okay,
Quadratic.
24x square, just that. What is the name? Quadratic. Getting it?
Yes, ma'am.
Okay, so while checking the name, you will always check the degree first. Now, the last one, when the degree of the polynomial is 3, when the degree of the polynomial is 3, for example, our polynomial may look like 2y to the power 3 plus 24y square plus 30. Degree is 3. Hence, the name is cubic polynomial.
Cubic.
This much we need to keep in mind. Clear?
Yes, ma'am.
Okay, let's continue. Now there comes the next concept, that is zero of the polynomial, which is really, really, really important, because our class 10, the whole concept in this chapter is based on zero of the polynomial. Okay, we are checking the relationship between zeros and the coefficients. Okay, and in the graph we are trying to find the zeros of the polynomial, right? How many zeros are there, right, Salva?
Yes, ma'am.
Okay, so first the concept started from here, that in case we are having a polynomial, for example, in case we are having a polynomial x minus 5, what is the zero of this polynomial?
1.
Okay, so zero means if I'm giving you this polynomial px is equals to x minus 5, you know we can represent the polynomial like this, right?
Yes, ma'am.
Okay, this is just representation. So if a polynomial is given like this, x minus 5, which is a, what is the name of this polynomial? Will you be able to tell me, Salva?
Linear.
Yeah, it is linear. Okay. If we have to
Okay.
find the zero, what we will do, we will try first,
We will
let's guess it. What is that particular x value which I will put over here, and will subtract our minus 5 from there, and the result will be 0. What should I put over here. At the place of x, what can be taken so that the final answer will be
Zero.
0? No. Positive 5.
Uh,
5
oh,
minus 5
okay,
is
okay.
0, right?
Yes.
Okay. So 0 of the polynomial means that particular x value when we are putting in the polynomial and the final answer is 0. Okay. If I am giving that our polynomial is x plus 8, then what will be the 0 of the polynomial? Just try guessing it.
X plus 8.
What can be taken as a x value? Plus 8 or minus 8? Which I will put
Minus
over
8.
here. Minus 8, right? Then only I will add 8 to that and the final answer will be 0. This x value,
0.
which is minus 8, is called as is 0 of the polynomial. Why? Because it is, okay, this particular value when we are putting, it is making the whole
We get
polynomial's
0.
answer as a 0. Okay. So 0 doesn't mean x will be 0. 0 means what is that x which is making the whole polynomial as a 0? Okay. X equals to minus 8 is the 0
The value
of
of
the
X.
given polynomial. Now this is, here we are guessing, but always this guesswork will not work. Okay, so there is a proper method for finding the 0. This is the meaning of the 0. Okay, why at first I am telling you to guess it? So that you should realize, you should understand the meaning of the 0. That okay, we are searching that particular x value, which when we are dropping in the polynomial, the final result is becoming 0. Okay, now
Okay, ma'am.
you realize that okay, this is the meaning of the 0. There is a proper method for finding the 0, that in case you want to find the 0 of a polynomial, what we can do, in case we want to find the 0 of this polynomial px is equals to x minus 5. Okay, in case we want to find the 0 of this polynomial, the method, the process says that take your polynomial, okay, just take it as it is, x minus 5, and just write equals to 0 by
Equal
yourself.
to 0.
Okay,
Okay.
just take the polynomial and write equals to 0 by yourself and try finding the x value just by solving the equation by using class 7, class 8 method. Okay, you will be getting x value. That x value is called as the 0 of the polynomial. Getting it?
Yes, ma'am. I've
Okay,
learned it.
yeah.
I mean, I remember learning it before.
Yeah, you must have learned it. And the same rule we follow in our class as well, 10. Okay. That
Okay.
whenever we have to find the 0, we take the polynomial as it is, we write is equals to 0, and we try finding the x value. That x value is not any random x value. That x value is that particular x value which was making our polynomial 0. Okay.
Okay.
So in case we are having px is equals to 2x plus 8, can you tell me what will be the 0 of this polynomial? Not by guessing, by using the method.
Okay. I'm doing it in my book.
Yeah, take your time and do it.
Minus 8.
Minus,
8.
is it minus 8? Is it? We will be taking whatever polynomial we are having, will be taking is equals to 0. And then forget about everything and focus on solving this equation by using class 6 or maybe class 7 method. What is the x value? 2x plus 8 is equals to 0. Then x will be, this 8 we will be shifting to the other side. It will be 0 minus 8, right?
Oh. Oh, what? minus minus 8. Sorry.
No, okay, it's not -8. We are trying to find the x value, right, Salva? So x will be -8
4, 4,
+4 or -4.
minus 4.
Yeah, any doubt?
No, no. I
Okay,
was a bit confused.
no worries. I'm giving you few more polynomial. Please find the zero and tell me quick, quick, quick. Okay, number one is
Okay.
px is equals to 16x plus 32. Find the zero.
Okay. Got it, ma'am.
Yeah, what is the zero of the first one, Salva?
Minus 2.
Perfect. And what is the zero for the second one?
I didn't do that. Wait.
Do it. Take your time and do it.
2.
Okay, x is just two. Okay, yeah. So this is how you, okay, that's the meaning of the zero. Now here in our class 10, you will see a polynomial px. Basically, the whole story starts from the graph. Okay, so
Okay.
let me show you few things about the graph, then I'll be starting with that assessment. Just a moment. You have noted, right, what the polynomials which I had given, Salwa?
Yes, ma'am.
Okay, just a second.
Not all, but few.
Yeah, yeah. I don't need all of them. I just want to show it to you. You need to dictate the polynomial to me so that I can write it over here and show you something. Can you see this screen?
Black screen?
No?
Yeah, now I can see. Graph.
Okay. Yeah, graph. Can you tell me what was the one of the polynomial, okay, where you found the zero, x equals to 2 or maybe x equals to -2? What was the polynomial? Px is equals to what?
X is equal to 2.
15x minus 30 we were having, or what?
Yes.
Can you see the graph? Red color line.
Yes. Yes, ma'am.
Okay, you have found the x value as a 2 and confidently you are declaring that is the 0, right?
Yes, ma'am.
And how you got the 0? You have worked on it. Okay, you compared it with 0
Yes,
and you
ma'am.
found the x value. And can you see the graph is touching the x-axis
Yeah.
at x equals to 2, which you have found? Yes or no?
Yes, ma'am.
So if we are saying wherever our graph is touching the x-axis, that point is the 0,
Is the
we are not
zero?
we are not doing any mistake, right?
No, ma'am.
Okay, and even you have also worked on one more question. Okay, let me check what was that.
16x plus 32.
Yeah, 16x plus 32. Let me take it over here and let me show it to you. Because when we will see it, then our mind will get convinced that, okay, so here, if we are having 16x plus 32, you got 0 as a minus 2, right?
Yes.
And can you see the line is touching the x-axis at this point only?
Yes, ma'am.
Okay, that's why in the first exercise directly you must have learned that wherever your graph is touching the x-axis, just tell that those are the zeros, right?
Yes, ma'am.
Okay, and that is the reason behind it. It works for linear polynomial, it works for quadratic, it works for cubic, it works for all the polynomial. But cubic and all is beyond our scope for now. Yeah, we can have the graph and we can just count how many zeros are there, or maybe we can check what are the zero, just like this here minus 2 is the zero for the blue color graph, and for the red one x equals to 2 is the zero, right?
Yes.
Yeah, so we'll be continuing our discussion from here. The whole next class I'll be explaining you what is quadratic polynomial, how the graph behaves, what is the name of the graph. Okay, when the graph is upward facing you, when the graph is downward facing you. Okay, I'll be showing everything to you over here. When you will see it, you will understand it really well. But I have to take it in the next class. Let me share that paper. So far, any confusion, Salwa?
No, ma'am.
Okay. Just give me a moment. I'm sorry. Can you see the paper, Salva?
Yes, ma'am.
Okay, you have to solve these questions and you have to tell me the answers directly. Okay, the first one, even you don't need pen and paper, directly you will be able to understand what will be there in the fill in the blanks. Okay,
Okay. First one is minus 5,
yeah,
minus 8 plus minus 5.
okay, yeah, you tell me, I'm noting down over here. Yeah, next one.
0,
Yeah, it is. Next one,
0. No, sorry, sorry. 17, 17.
positive or negative?
Minus 17.
Yeah, next one,
Mm, -7.
Yeah. Wait. Number 5. Is it minus 7?
4, 4.
Yeah. Number 4 is minus 7. 5.
-3.
Yeah. Perfect. Next. HCF of 18 and 48. Take your time. Use pen and paper and find it.
Okay. Uh, 6, ma'am.
Yeah.
First one.
Yes, it is. Next one.
6, ma'am.
Yeah, perfect. The next one, number 3. Here also you don't have to use pen and paper. Directly you should see and tell me what will be in ascending order, what will be in descending order.
1 by 5.
Ascending,
1 by 7.
ascending
Yes.
order. Okay, I want to give you one example. Please write it in your notebook.
Okay.
Yeah, write 100 by 2,
100 by 2.
comma 100 by 50.
100 by.
50.
Okay.
And tell me which one is bigger, which one is smaller. You can cancel them out because here it is possible.
Okay.
Yeah. Can you see 100 by 2 is 50 and 100 by 50 is 2? That means when the numerator is same, smaller
2.
denominator will give you larger value. Yes or no?
Oh, yes.
So here we cannot say that 1 by 5 is the smallest one. We can't. So which one is the smallest one? The largest denominator. Making sense?
1 by 50.
Exactly. Got it?
Okay.
So ascending order will be
1 by 50, 1 by 23, 1 by 17,
yeah,
1
I'll
by
write it.
12.
Okay, you got it. Do number 4. I'll write the descending one as well. You do number 4.
Okay.
And yeah, just check the both sides are same or not. If same, what is the answer?
Okay. Ma'am, I'm finding it difficult to do.
No worries. You can skip number 4. You can do number 5.
Okay.
we need to find the perimeter of the rectangle, Salwa. If you are getting confused, uh,
No, I'm converting 150 centimeters into meters right now.
yeah, yeah, okay. Better you convert 1 meter in centimeter. Better you convert 1 meter in centimeter, then both will be in centimeter, and easily you will be able to find the perimeter.
One. Ma'am, is the answer 5 meter?
Yeah, it is. Okay. Next,
Sixth one.
yeah, 6.
Ma'am,
Yeah.
I'm not able to do that.
Okay, number 6, you can skip. You can tell me, is 90 a perfect square number, Salwa?
I have to solve it.
You can check it. Is it a perfect square? If it will be there inside the root, will it be possible for us to take it out from the root sign? Because 4 is a perfect square number, 9 is a perfect square number. Is 90 also a perfect square, just like those numbers?
No, because two numbers.
Yeah, it is no. Okay. Please do the next one. Okay, the last one. Yes, it is not a perfect square number. Yeah. The last one, Salva, we need to split the middle term. Will you be able to do the factorization?
Yeah, I remember doing that.
Yeah, do it.
Ma'am,
Yeah. What are
is
you
it
getting?
uh, is it z plus 3 bracket
Bracket?
z minus 5?
Okay, so yeah, I'm writing over here. Okay, I'll check whether the responses are correct or not, Salva. And yeah, I'll inform to you. Okay, and we'll be discussing it. Don't worry. Okay, wherever you are
Okay.
having confusion, we will be discussing it. And if you are thinking it's already too late, okay, you how you